Okay, let's do number 4. If you guys want to go back to this. Now, with this number 4, what I did was put these two things in my calculator because it wanted to know the interval. Now, notice that when it did the interval, it just left this margin of error here just calculated out. So there's a couple ways you can go about doing this. First of all, the first thing is that I went into my calculator and I put into list 1 the before, I will put into list 2 the after, and then in list 3 I put L2 minus L1. Okay, so there's the difference. So you can see the first one from 3 to 7 went up 4, and so on. Okay, so one way that you can do this is go and actually compute the interval by hand. And the way you can compute the interval by hand is by getting the important information of list 3. You need the mean and its standard deviation. Okay, so you can go and get the important information from list 3 by going second vars. Oops, that's wrong. Just vars. That's right. Whoop. Okay, so excuse me, stat over to calc. All right, one variable stats, and you have to put in list 3 here, okay, so that it'll calculate the list 3 data, not list 1. And so when I calculate this, then I come up with my x bar, which is the mean of x, is 11.61, and this standard deviation, S of x, 4.89. Okay, so that's what I have listed right here. All right, from that, then I know I want to be 95% confident, so my critical value is inverse t of 1/tail, comma, degrees of freedom. The degrees of freedom is 8 because the sample size right here was 9. So I compute inverse t of 1/tail, comma, degrees of freedom. So here's this. So what I did was I mathematically determined this here, which is my critical value times the standard deviation over the square root of n, and when I calculated that, it comes out to 3.76. Okay, so that's the brute force way. Now there is another way you could do this, and that would be if you went through here and you calculated the interval. So I went stat tests number 8, and I want to do the t interval of list 3. And so if I come and I do that, then I get this interval from 7.85 to 15.371. Okay, so I say to myself, okay, I need to go from 7.85 to 15.371, and now I'm going to go and guess and check which one of these down here gives me that answer. And if you take 11.61 and you add that 3.76, you get the top number, 11.61 minus 3.76, and you get the bottom number. Okay, so you can guess and check without doing all this other stuff by hand. Okay, that's another option. Okay, number 5. Okay, I just read this problem, number 5, and I could tell that it was a 2 separate groups of mice. See, that was kind of one of the first things I had to do. It was 2 separate groups of mice. One set of 10 was on the old diet. The other set of 10 was on the new diet. So I just put in my data into a 2 sample t-test for means, and I got this p-value right here, which is obviously below 0.01. Okay, so that was just a straightforward recognizing that as 2 separate groups of mice. I think that was the tricky part. I wanted to just make sure it was not paired mice that were on the first diet and then on the second diet. Okay, number 6. 6 is a straightforward, if you want to be 90% confident, you've got 90% in the middle, so you've got 5% here. So it's inverse t of 1/tail, comma, 14 degrees of freedom, and again it's 14 degrees of freedom because the sample size is 15. That's 1.761. Okay, number 7 is a big one that people are still missing, so I'm going to go through that one carefully. Okay, so here we go. first of all, with number 7, you know that your interval is plus or minus critical value times this standard deviation. Okay. All right. Now, here's my first question. What is the name of this component after the plus and the minus? Okay, that's the critical thing. This is the margin of error. So you can make an equation from this stuff in red, and you can say the margin of error equals the critical value times this standard deviation. All right, so if you look at the problem number 7 here, it says the margin of error is 0.07, so I fill that in. And in order to do this, 94% confidence level comes from, if 94% is in the middle, then what is in one tail? Okay, I got 0.03, so I'm going to do this, inverse norm. It's inverse norm. It's not an inverse T. You know why? Proportion problems are always z-scores, so it's inverse norm of 0.03. And how did I know this was a proportion problem or a percentage? A social scientist wished to determine the differences in the percentages. So they're estimating the difference in the percentages. Okay, and guess what? They did not give me a p-hat value. So if they do not give you a p-hat value, then guess what you use? Your 0.5. So, in summary, here's your equation that you have right here, and then from there it's algebra to figure out and solve for n. And again, I knew I was solving for n because it said how large of a sample, so that means solve for n. So I have all of the numbers except for n, and I can do algebraically the computation. Okay, that's it on that. Number 8 is going to be similar to the one up above. Just got to figure out what that is right there. And so you can kind of do the calculator stuff backwards, or let's see. Sample size is 100, so degrees of freedom is 99. T star is inverse T of one tail. Why is it one tail? 0.01. Okay. 98% in the middle. Each tail is 0.01 with degrees of freedom 0.99. So that's my 2.36. And then they tell me the standard deviation is 0.4 ohms. That's a symbol to represent the units for the resistor. Okay, so 0.4 over the square root of n, and when you compute that, that's your 0.0944 closest to A. All right, any questions on the page 5 through 8, or 4 through 8? Okay, done with that one.